Okay, so let's start. After Doberia triad, who came? Newland law of octaves. What he was saying? The elements are arranged in such a way that every each element has the property of the first one. This is advantages. This is not applicable to the all the elements because D block, F block element when it exists when it came, it was not applicable to them. Along with that, when the noble gases were included, the noble gases were the eighth element. It was not having the property of the first one. Okay. After that, what we have done? Which one? Mendeleev. Under Mendeleev, the important thing is that Eka aluminum, Eka silicon. He has already before finding the element, he said there will be an element whose properties will be like this. He has already told. And which are the elements? He has marked that Eka aluminum, Eka silicon, what it is called as. Eka silicon is what germanium, no? Eka aluminum is check what it is. Gallium, yes or no? Then we have technetium. What is technetium? He has given as Eka manganese. And one more is there, no? Eka boron, what it is? Scandium. Okay, so out of this, for a question can come only for the like 1 mark question can come or a MCQ can come. After that, we are studying model periodic table. Yes or no? Model periodic table. What it does depend on? Mendeleev's periodic law is depends on what? What does it law say? The physical and chemical properties of the depends upon what? Atomic masses. Exact borobar, whatever they given in the notes. Then what does modern periodic law says? Same thing, but it depends on what? Atomic weight, atomic number. Okay. So with this we have done. Then we have studied with the S block elements. Group 1 and group 2 are called as what? S block elements. You can just refer the notes for that. Confidence. Okay, just go through this. So S block elements are called as S block. Why? Because the last electron enters into the S subshell. So group 1, what is the general electronic configuration of group 1? NS1, group 2, NS2, group 1 and full S block element, NS1 to 2. P block elements. Why the P block elements are called as P block? Last electron enters into the P subshell. So general electronic configuration. So it starts from group 13 to group 18. So NP1, NP2, NP3, NP4, NP5, NP6. So what will be for P block? NS2, NP1 to 6. I will just write for one P block. Huh? Yeah. That's why I bring my markers. काला काला हो गया. माझ्याच कारणामे एव्हरीथिंग जे ब्लॅक झालं पण आउट तो फुल मार्कर बरोबर होय मग Okay, what I was discussing about NS2 NP6. So boron electronic configuration किती आहे? 1s2 2s2 2p1. You know what mistake I made yesterday? We just focus on boron जातरे कोण असा? बोरॉन जातरे कार्बन electronic configuration किती आहे? 2p2. What mistake I made yesterday? Electronic configuration something. In the flow, I was just going and going. What is the shortcut method here? Helium, correct me? 2s2, 2p1. So I will just write the whole thing again. Kiti, I mean mistake. What mistake? It was made by me, not you all. It was made by me. So group 13 elements, I will just write group 13 and group 14 and group 15. 13 elements, 16 also, 17, 18. Okay. So I have here boron, magi carbon, magi nitrogen, magi oxygen, magi fluorine, and magi neon. So boron jatre anyatla boron, aluminium, carbon jatre silicon, nitrogen jatre aluminum silicon, phosphorus, sulfur, chlorine, argon. Correct, no? So boron, aluminium, gallium, carbon, silicon, germanium, nitrogen, phosphorus, arsenic, oxygen, sulfur, selenium, chlorine, bromine, neon, argon, krypton. Okay, I will just write electronic configuration. It was half we have done P block elements. 1s2, 2s2, 2p1. Okay, I will write for this. This will be aluminium for 1s2, 2s2, 2p6, 3s2, 3p1. This will be 4s2 4p1. This will be 4s2 4p1. Okay. Now what happens here? S is also there, no? Correct, no? We have focused only on whom? P. But S is also there. So the actual electronic configuration is 1s2. I will write it as helium. 1s2 I will write it as what? Helium. So it will be 1s2, 2s2, 2p1. Correct? What will be for aluminium? This part I will write it as what? Neon. So 3s2, 3p1. So can you tell me the general electronic configuration for group 13? It will be noble gas. It will be noble gas NS2 NP1. Noble gas NS2 NP1. What will be for group 15? It will be again noble gas, then NS2 NP. This will be NP2. This will be NP3. Understand, Zala? General किती असतं सांग? General P block. Noble gas NS2 NP 1 to 6. Clear, sir? So just make a note of these things if you have written somewhere. Okay, just check our notes sample same दिल झाला है. Noble gas NS2 NP 1 to 6. Clear? Open the Xerox one. ना ये ना काहींची गरज ना रिटर्न ना काय Xerox one open करू पाहिजे. Open the Xerox one. Understood now, everyone? NS2 NP 1 to 6. Clear? So the first page, I will just go to the modern periodic law is given. The long form period one. What are periods? Horizontal or vertical? Horizontal and vertical. Which are the periods? Horizontal one. How many periods we have? 7. And groups we have 18. In the first period, period number 1, how many elements are there? 2. Which are the 2? Hydrogen and helium. But actually hydrogen आम्ही मध्ये होता फिर we don't keep it on the first period, but we consider it is in the first period. Second period कितने elements असतात? 8. Third period कितने असतात? We'll go with this. First period corresponds to n is equal to 1, that is orbital 1s. It consists of how many elements? 2 elements. Just mark it consists of 2 elements. First period, it consists of 2 elements. It consists of 2 elements. First period, it is written there. First period consists of 2 elements. Just mark that there 2 elements. Second period, it consists of how many elements? 8 elements. Third period, it consists of 18 elements. Okay. Fourth period, it also consists of 18 elements. Fifth period, it also consists of 18 elements. And sixth period, it consists of 32 elements. Okay, this much you should know. Ata elements not required as much, but at least first 3 periods you should know which are the elements present. In the first period, there is hydrogen and helium. In the second period, which are the elements? See, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Lithium to neon. Then for the third period, it will be sodium to. See, hint is it? Okay, I will give you the hint how to remember. It will end with noble gas. Element start the boy to end noble gas ends boy, that is the last element. For example, see, hydrogen, helium. Hydrogen start the helium चे सोपलो 2 element. Third element कोण lithium. Lithium जाते next noble gas कोण आम गेलो? Neon. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Neon जाते माहिती कोण start आता? So sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Argon जाते माहिती कोण start आता? Potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, copper, nickel, copper, zinc. After that, it will end with helium, neon, argon, krypton. So noble gas elements, whatever are there, where that in the order, if the noble gas comes, that is the full period. It will be full period. Clear, sir? So like this, just remember 3 to 4 period elements. 3 period elements that will cover our 1 to 30. 3 periods will cover our 1 to 30. That's the 1 to 30 is important. Okay. So you understood the general electronic configuration now. For S it will be NS1 to 2. For P it will be noble gas NS2 NP 1 to 6. For D block it is what? For D block also we can write noble gas, huh? For D block also we can write noble gas. If you are not writing, which I will not cut your marks, but we don't know. So better, because if I write for scandium, it will be what? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d1. So this part will be what? Argon. So noble gas. That will change for every element. Noble gas will change for every element. So generally it will be what? Noble gas. Then I told you how to write NS2. Then it is NS what? 1 to 2, correct? Because for chromium and copper, 4s is what? For chromium and copper, 4s is what? 1. So it will be 1 to 2. And what this will be? N minus 1 नी 4s असल्यार 3d असतलो 5s असल्यार 4d असतलो 4s असल्यार sorry yes okay so n minus 1 d 1 to 10 this will be general electronic configuration. Let me write again scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. See here this is argon 4s2 3d1, correct? 4s2 3d1. What will be called copper, chromium, argon 4s1 3d5. What will be for copper, argon 4s1 3d10. And for what will be for zinc, argon 4s2 3d10. So like this for the after scandium there is zirconium, there is vanadium, chromium, vanadium, chromium, zirconium, manganese, iron, cobalt. Okay. So for this element it will be argon, which noble gas comes? Krypton. Argon which noble gas is krypton. 4s2 will become to what? 5s2. 3d1 will become what? 4d1. You have the periodic table with you. You have the periodic table with you. Asa textbook asa konaकडे. Okay, so I will tell you the atomic number. After this, just check on the periodic table. On the periodic table, after scandium, just check. Ytterbium will come. Yttrium will come. Why? After titanium, zirconium will come. Okay, so there, just check. It will be the atomic number 39. Atomic number 39. Here 39. The electronic configuration is 4d1. Sorry, 5s for the last 4d1, 5s2. 4d1, 5s2. 4d1, 5s2. 4d1 I can say 4d1, 5s2. So like this, argon, krypton, what will be the next one? It will be xenon. So noble gas will change, so noble gas will be there. NS is 1 to 2, no? Because for chromium we have 4s1, for copper also we have 4s1. Like that, under chromium there will be 4s1 as 5s1. Under here it will be again 5s1. So like this, 3D also 1 to 10, no? So like this it will become NS 1 to 2, N minus 1, 1 to 10. So noble gas, don't forget this noble gas. Understood? Don't forget the noble gas. Clear? Okay, so this is for the D block elements. Other D block elements are a points before I go with the topic. D block elements are also called as transition elements. D block elements are also called as transition elements. What are transition elements? Transition elements are those elements whose d orbitals are not fully filled. Transition elements are those elements whose d orbitals are not fully filled. So out of this, can you tell me which is not a transition element? Zinc. Because why? D is fully filled. So what about copper? See, actual electronic configuration is 4s2 3d9, no? Actual. एक electron jump था. So zinc, then we have zinc, the last element in the D block. They are not a transition element because what is the reason? Because it is not having any unpaired electron in its d orbital. What I'm saying, zinc is not a transition element because in the d orbital there is no unpaired electron. आता म्हणटले सर कॉपर सुद्धा फुल्ली फिल्ड आसा न्ही कॉपर सुद्धा फुल्ली फिल्ड आसा बट इन द कॉपर ऑल्सो स्टुडंट एक्चुअल कितें आसता आमगेलें 4:3D9 मागीर तो जम्प जाता टू अटेन दॅट स्टेबिलिटी बट झिंका भितर ओरिजिनल इज लायक दॅट नो 4:3D10 सो झिंक इज नॉट अ ट्रान्झिशन एलिमेंट क्लियर आसा okay so under zinc whichever the elements are there they are all not transition elements and why d block elements are called transition elements because of presence of at least one unpaired electron in its which orbital d orbitals understood transition element what are transition elements are those elements which have at least one unpaired electron in its d orbital so open page number 2 page number 2 see there is can you see that d block elements the general electronic configuration noble gas is not written but actually बरोवपाक जाय सारकें न्ही actually it should be written so it is not written no problem परत सांगता if you are not writing noble gas teacher can give you marks but actually it should be there yes or no noble gas same उरता सगळे कडेन काय चेंज जाता चेंज जाता same उरता as the periods are changing noble gas are also changing for a single period it is changing if I tell you to write an electronic configuration of 1, 2, 3, 4. So group 4, what you will write? General electronic configuration of D block group 4, group 4. Group 4. It will be noble gas, then NS2. Will it be NS2? Yes. Then N minus 1, N minus 1, D2. See, I will just be with me, be with me. It will be noble gas, argon, krypton, xenon, noble gas will come. Yes. 4s2 will be common here. So it will be 4s2 means NH2. Because here 4s2, here 5s2, here 6s2. So it will be NH2 here. What about this one? N minus 1. 4s aslang 3D, 5s aslang 4D, 6s aslang 5D. So N minus 1D and it will be what? 1. Understanding? Understanding? So if I tell you to write for 3, 4, 5, 6, chromium part, chromium group 6, what you will write? Noble gas, NS 1, then N minus 1, D 5. Understand that? General, you know. Check out my groups. 1 to 2 is what? Group 1 to 2 is what? S block. Magir amgele 2 to, sorry, 3 to 12. D block element. It also cover F block. F block ache total करपाचे नाही. Just general electronic configuration करून sir. F block ache. But D block element, you know, 3 to what? 12. 13 to 18. 13 to 18, P block. Like this we should. Clear Asada? Okay, just under the D block, no, that one paragraph is given. See, however, zinc, cadmium, and mercury, which have electronic configuration N minus 1, D to 10, NS2. Are you understanding the electronic configuration now? Everyone is understanding? Crystal, are you understanding the electronic configuration? Little bit at least. Daniela, okay. Do not show most of the properties of transition elements. Why? They do not show. No, do not show because the d orbitals are what? Fully filled. Zinc, cadmium, mercury. They are in the same group. Zinc, cadmium, and mercury. Because the d orbital is what? Fully filled. Why they are not considered zinc, cadmium, mercury? Zinc, cadmium, mercury are not considered transition elements because the d orbitals are fully filled. Because the d orbitals are fully filled. Because the d orbitals are fully filled. Joseph, how are you? At what time you wake up? Yeah. 6:30. At what time you slept? वेदा कितल्या न्हिदलेलो राती अराउंड आफ्टर 12 आफ्टर 1 o'clock बेगीन न्हिदलेलो म्हाका ती एक गोल पडटा ते बंद केला म्हाका ते जिखतो म्हणून म्हाकाय मॉर्निंग उठपाक जाय आसलें न्ही I was totally tired. Full day, म्हाका hectic आसता सामकें. I felt like My time limit is very less to come in the coaching class and see. हांव जर फुल एनर्जीन तुमकां शिकयना न्ही आय जस्ट गो ऑन रिडींग हे माफ कर म्हटलें न्ही तुमी बेजारतले म्हाजेर देन आय हॅव फॉर 12th ऑल्सो म्हागे रूल एक आसा आय एम टेलिंग यू डायरेक्टली हांव म्हाजें मोठेपण सांगना म्हागे एकच रूल आसा इफ आय एम एक्सप्लेनिंग समथींग इट शूड बी माय फुल कॉन्फिडन्स काल हांवें तें म्हागे तें मॅजीक नंबर चुकलो म्हाका कितले बिकॉज जालें मागीर हांवें वर्क ऑन द पी ब्लॉक एलिमेंट पी ब्लॉक थिंग ओके सो एक बारीकशी मिस्टेक केलें आय विल टेल यू दॅट आफ्टर वॉट मिस्टेक दॅट मॅजीक नंबर नो पी ब्लॉका न्ही मास्तर चेंज जाता असे तर रूल चेंज जाता फॉर पी ब्लॉक जसो आय वॉज नॉट गेटिंग दॅट एस ब्लॉका म्हाका करेक्ट मेळटलो हिलियम ग्रुप 18 म्हाका करेक्ट मेळटलो मदींच कितें तर चुकलें म्हाजें आय विल टेल यू वॉट इज द मिस्टेक ओके सो लायक दॅट मागीर म्हाका टेन्शन जाता अरे बाबा मागीर कितें तरी चूक जालें सो देन आय सिट विथ द पी ब्लॉक आय पयलें देन आय केम टू नो अरे बाबा I have told you only NP 1 to 6. I have not told you about NS2. Magir म्हाका याद जालें why NS2? I told you about a noble gas to write a shortcut. Then why I not written noble gas there? See, एक पॉइंट मिस जाल्यार सगळें जालें. मागीर आज म्हटलें आज सगळें आयल्या पुरो I will explain that noble gas. Now you understood, no? कित्याक नोट्साचेर noble gas दिनात. Noble gas दिना नोट्साचेर. And the reference book also not given. But actually noble gas should be there. Noble gases should be there. Just bracket a noble gas you have to write. Don't mention the noble gas. Clear? Okay, so zinc, cadmium, and mercury are not considered transition elements because their d orbital is fully filled. Because their d orbital is fully filled, right? In kit. Zinc, cadmium, okay. Their d orbitals are fully filled. Full. Next year, for us, sometimes DNA block, हमको full chapter DNA block. Okay. So with this, the chapter is just started. With this, the chapter is just started. Now, the heart of the chapter. म्हाका full जाय जाल्यार एक 2 मिनटांचो ब्रेक दिता have water म्हाका full half an hour 45 minutes म्हाका full concentration जाय it will be interesting don't worry it will be interesting these are the application questions which are asked you should know the basic things so it starts from page number 3 what happened Ray? What's the score जिंकले रे आता पण कर hitting करा हेड आता how it is possible after 90 minutes only they score 2 goals after every match not possible नहीं तो अर्जेंटीना फैन रियल मैड्रिड फैन you are a sports person इस फुटबॉल का क्या नहीं बॉडी लैंग्वेज से अरे स्पोर्ट्स पर्सन लाइक कैसे चलता है ओके सी स्टार्ट the first concept which you have to understand पूरा निकले थे okay just watch the semi-final Spain and it will be too good penalty चे पावतली don't know Spain is a danger team आणि काही 4 गोली घेतल्या उगी रावतले okay so let's start मातशे थोडे मिनिटां खातीर सायडीर दवरया the first concept what we will study is the atomic radii which can be also called as atomic radius examine the definition I will write the same thing just see the term atomic radius means the distance from the center of the nucleus to the outermost shell of electron what is atomic radius same thing आम्ही सर्कलाचो कसो रेडियस काढता like this if this is my nucleus if this is my shell the distance from the outermost shell to the nucleus is called as what atomic radius but म्हाका एक सांग पळया एटम घेतलो एटमा भितर कोण असता न्यूक्लियस अराउंड कोण असता शेल शेला भितर कोण असता सबशेला भितर कोण असता ऑर्बिटला भितर कोण असता इलेक्ट्रॉना कितें असता स्पिन आयदर क्लॉकवायज ऑर एंटी क्लॉकवायज अशें रुलर घेतले आनी अशें मेजले म्हणून आमकां रेडियस मेळटलो is it possible to find actually but there are some techniques also like x-rays and all we can find but exact radius atomic radius karpa it is very difficult possible ना how minute the atom is yes or no दिश्टी पडटा दोळ्यांनी आणि तो झूम करून सुद्दां कितलोय पळय with the whatever methods we have is it do you think it is possible to find atomic radius no एक सांगता if माझो न्यूक्लियस जर हांगा आसा न्ही around 5 किलोमीटर डिस्टन्साचेर आमची शेल्स उरतात 5 किलोमीटर फ्रॉम हियर अराउंड काय सांगला टिचरीन ना आमचो तो न्यूक्लियस आसा न्यूक्लियस कंटेन्स वॉट प्रोटॉन्स एंड वॉट न्यूट्रॉन्स तेच तो एटॉमिक नंबर आमकां कसली इन्फॉर्मेशन दिता नंबर ऑफ protons. Yes or no? Number of protons. If it is a what I can say in the element form, atomic number is also equal to number of electrons. But as एक electron गेलो, एक electron less झालो, size will remain same, atomic radius will remain same. Example दिता. Consider कर माझ्याकडे 5 प्रोटॉन असतात. एलिमेंट स्टेट माझ्याकडे 5 प्रोटॉन असतात आणि किती इलेक्ट्रॉन असतात? 5 इलेक्ट्रॉन असतात. फोल्ड करून दवरतना इलेक्ट्रॉनाक नेत्रावती आयलो राव आणि एक इलेक्ट्रॉन काढून घेऊन गेलाय. ट्राय टू अंडरस्टँड. एक इलेक्ट्रॉन काढून घेऊन गेलाय. आता हो फोर्स ऑफ अट्रॅक्शन चड जातलो न्ही. इट विल बी मोर येस ऑर नो. सो ऑटोमॅटिक रेडियस विल व्हॉट? Increase or decrease? Decrease. Okay, so this is about atomic radius. So definition is it's a distance from the center of the nucleus to the outermost shell. Outermost shell. It depends on which shell the last electron is present. Whether it's present in the fourth shell, third shell, second shell. So like that, it's the distance between the center of the nucleus to the outermost shell. Understood atomic radius? Any doubts here? Clear? Okay, next point. Mark करून दवरते. So there are it is determined because of following exact radius cannot be determined because of the following reasons. Because the atom is not well defined boundary na teka possible isolate atom blah 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 blah. Ata the important thing here. Depending upon the nature of bonding, जे सांगतो पण तेच याद धरा. That is important. Atomic radius मला कितने कळे आमका? Okay, atomic radius, the distance from the center of the nucleus to the outermost shell. The second point, the third line. Atomic, depending upon the nature of bonding in the atom, these are called as covalent radii, van der Waals radii, and metallic radii. Covalent radii, van der Waals radii, and metallic radii. Ata some new words for you. So understand them here. What is covalent radii? Covalent radius. Definition is given. I will just go through the definition again. Covalent radius for non-metallic element is defined as 1/2 of the distance between the nuclei, internuclear distance of two covalently bonded atoms in a homodiatomic molecule. See, if carbon and carbon is making a bond, this is a covalent bond. आता हे फर्स्ट कार्बन आणि सेकंड कार्बन. फर्स्ट कार्बनाचं न्यूक्लियस असतलो करेक्ट. सेकंड कार्बनाचं न्यूक्लियस असतलो. दोघांनी इलेक्ट्रॉन शेअरिंग करून हांगा बॉन्ड केला. इलेक्ट्रॉन जर शेअरिंग करून बॉन्ड जाता दॅट इज कॉल्ड एज कोव्हॅलंट बॉन्ड. Fourth chapter, chemical bonding and all, we will go in detail about this covalent bonding. Chemical bonding and molecular structure. The name of the chapter is chemical bonding, molecular structure. आता बस इन्फॉर्मेशन खाती सांगून दवरता. Sharing of electrons जर केल्यानी आमकां कसली बॉन्ड मेळटा? We are getting a covalent bond. आता this bond is made by the electrons. So the distance between the nucleus, center of the nucleus of the first carbon and the distance of the center of the nucleus from the second carbon, या दोन्ही distance आम्ही किती म्हणटले? Covalent radius. Consider if I am making a bond with this, there's a center of the nucleus and mass center of the nucleus, as a distance असतले, that will be the covalent radius. Understood? आता हे understand जातले. आता परत वाच. It is defined 1/2 of the distance between the nuclei. So 1/2 म्हटलं किती? For full nuclei नी 1/2 म्हटलं वजालो. याचा 1/2 झालो. Okay, 1/2 of the 1/2 of the distance between the nuclei of two covalently bonded atoms. Covalently bonded atoms in a homodiatomic molecule. Diatomic म्हटलं किती? दोन atom. It can be mostly same असतात. किती असतात? Same असतात. Homodiatomic. Diatomic म्हटलं दोन atoms. आणि homo म्हटलं किती? Same atoms. दोन diatomic म्हटलं two atoms आणि homo म्हटलं दोन्ही same atoms. आणि यांची दोघांचे 1/2 of the nuclear distance म्हणजे as a center of the nucleus plus as a center of the nucleus will give you covalent radius. Clear आता? Understand झाला? So what is atomic radius नेत्रावती? Atomic radius. Yeah, covalent radius is different. It is under atomic radius actually it is. But meaning much different असतो. What is atomic radius? कोण वर्षा सांगो? कोकणीन सांग, मराठीन सांग, इंग्लिश सांग, हिंदी सांग. Center of the nucleus to the outermost shell of the atom. Okay, and what is covalent radius? बाहेर मारपाचे. पण understand झाला? जर या बाहेर जर केले याद ना झालं की सांगतले the distance between the two homodiatomic from the 1/2 of the nuclei of one atom to the another half of the nuclei of the another. कोण वर्सां बरोवन येवपाचें एक्सप्लेन करा मागीर दोन कार्बन काड कर एक्सप्लेन इट्स गिव कन्सेप्ट इम्पॉर्टंट मातशें कन्सेप्ट इम्पॉर्टंट बायहार्ट करपाचें only few definitions you have to buy that's it laws and principles that you have to buy clear asa covalent radius clear asa next part metallic radius just see I'm reading it again in case of metal a large number of atoms are closely packed and are held by metallic bonds it is defined as half of the internuclear distance between the two neighboring atoms of a metal is metallic crystal आता हांगा बी मिनिंग सेम जाता बट मातशें डिफरंट वे स्टुडंट्स आमचे जे मेटलिक असता न्ही मेटल्स दे आर एक्चुअली द एटम्स आर प्लेस्ड इन अ क्यूब फॉर्म असता क्यूब हांगा एक एटम 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 एटम एक म्हणटा आमी क्रिस्टल लॅटीस पॅटीस न्ही लॅटीस क्रिस्टल लॅटीस जस्ट क्यूब फॉर्म इज आमकां न्ही एक्चुअली 12th सॉलिड स्टेट म्हणून एक चॅप्टर आशिल्लो बेस्ट चॅप्टर इट वॉज रियली गुड चॅप्टर बट इट इज रिमूव्ड there these things were they explain detailed how the atoms are placed in a आता जर आम्ही एक मेटल घेता एक मेटलिक घेता आम्ही what I can say any metal thing compound we are taking how the atoms are placed in that so it is actually placed like this so what is saying ह्याचे दोन atoms असतात both atoms will be metals दोन्ही atoms किती असतले metals आणि त्यांचे इंटरन्यूक्लियर डिस्टन्स जे असतले that will be called as metallic रेडियस जेन्ना दोन मेटल एटम्स आता फक्त तुमकां एक वर्ड इम्पॉर्टंट असता दिस वर्ड सी इट इज एज हाफ ऑफ द इंटरन्यूक्लियर डिस्टन्स अंडरस्टूड हाफ ऑफ इंटरन्यूक्लियर म्हटल्यार कितें हाफ ऑफ द इंटरन्यूक्लियर म्हळ्यार अंडरस्टँड जालें सी एज अ न्यूक्लियस आसतलो सी दिस इज आर टू मेटल्स सो एज अ न्यूक्लियस आसतलो तेजो हाफ लायक दिस हाफ ऑफ दिस न्यूक्लियस सो हाफ ऑफ द टू इंटरन्यूक्लियर डिस्टन्सीस देन बिटवीन टू नेबरिंग एटम्स आता पळय मेटल सरफेस कितें आसा एक जर कंपाउंड आसा न्ही स्टुडंट्स आमचो एक कंपाउंड आसा न्ही ट्राय टू अंडरस्टँड दिस एक जर आमचे कंपाउंड आसा न्ही एक कंपाउंड आसा न्ही आता हो मेटल जो आसा तो हे मेटल बॉन्डेड आसतलो एका आसतलो दिस सायड इट विल बी हियर एज सो एज अ हाफ एंड एज अ हाफ मेटलिक रेडियस एज अ न्यूक्लियस आसा हाफ एज अ न्यूक्लियस आसा हाफ मेटलिक रेडियस एज अ न्यूक्लियस आसा हाफ एज अ न्यूक्लियस आसा हाफ मेटलिक रेडियस सो हेचे जे डिस्टन्स आसा बिटवीन द टू नेबरिंग एटम्स हांगा बी मेटल आसा न्ही बट हेज्यान हेजे डिस्टन्स जातले ना बिकॉज दिस इज बॉन्डेड टू दिस इज बॉन्डेड टू दिस इज बॉन्डेड टू दिस सो हेज्यान हेजे डिस्टन्स जातले सो द नेबरिंग एटम what is important the two internuclear distance between the two neighboring atoms that is called as metallic radius like similar what covalent similar as what covalent but we can covalent is little different because there is a covalent bond here in metallic radius it will be what type of bond it will be metallic bond. In covalent radius, it will be what type of bond? Covalent bond. In metallic radius, it will be metallic bond. And I know, must thirty bouncer वता but chemical bonding and molecular structure are clear करतो ना. आता I cannot go in the topic. What is metallic bond? How it is formed? Time waste आमचं. Okay, so just introduction करून दवरता दिसाखातीर. Okay, next is so मार्क करून दवरा डेफिनेशन केन्ना विचारतात यान वान डेर वाल्स रेडियस आता वान डेर वाल्स रेडियस पळय तेज्या डेंजर आसा वान डेर वाल्स रेडियस तेज्या डेंजर आसा इट इज डिफाइंड एज हाफ ऑफ द इंटरन्यूक्लियर डिस्टन्स अगेन सेम थिंग पळय हाफ ऑफ द यू अंडरस्टूड द मिनिंग ऑफ हाफ ऑफ इंटरन्यूक्लियर डिस्टन्स येस नाउ ऑफ द टू नॉन बॉन्डेड नेबरिंग एटम्स आता हांगा एक इम्पॉर्टंट वर्ड किती दिला नॉन बॉन्डेड थंयच्यान कोवेलंट रेडियस इज वॉट बॉन्डेड मेटलिक रेडियस इज वॉट बॉन्डेड एटम वान डेर वाल्स रेडियस इज वॉट नॉन बॉन्डेड आता एक एक्झाम्पल दिता कन्सिडर कर स्टुडंट्स कन्सिडर कर माझ्या फुड्यान पॉझिटिव्ह चार्ज आसा आनी नेगेटिव्ह चार्ज आसा एस पॉझिटिव्ह चार्ज आसा नेगेटिव्ह चार्ज एक्झाम्पल दिता दिस आयन कंटेन पॉझिटिव्ह चार्ज दिस आयन कंटेन नेगेटिव्ह चार्ज बोथ विल गेट अट्रॅक्ट टुवर्ड्स इच अदर एस वन अट्रॅक्ट जातले सो अट्रॅक्ट जावन न्ही दे विल नॉट फॉर्म अ बॉन्ड दे विल नॉट फॉर्म अ बॉन्ड जावपाना बट दोगांची भितर अट्रॅक्शन आसतलें सो दे विल होल्ड टुगेदर because of what force of attraction दोघांकय किती करतले एकमेकाक घट धरतले they will hold tightly with the what force of attraction they will not form a bond I am repeating again why they are together with the force of attraction so مثلا दोन जर atoms असतात how they are held together by force of attraction and the internuclear distance between the two will be called as what van der Waals radius Van der Waals is the name of the scientist, and he has discovered that he has the force of attraction. He has given the name as Van der Waals forces. He has given the name as what? Van der Waals forces. Name must be Van der Waals forces. So, what is atomic radius? Distance from the center of the nucleus to the outermost shell. What is covalent radius? Internuclear distance between the two atoms of the two nuclei of the homodiatomic atoms. What is covalent metallic radius? Internuclear distance between the two neighboring metallic atoms. What is Van der Waals forces? Internuclear distance between two non-bonded atoms. Clear? Yes. So Van der Waals is a force of attraction. It's not a bond. Van der Waals is not a bond between the two atoms. It's a force of attraction between the two non-bonded atoms. Clear as समझता? Okay. एक 2 minutes break give and we'll continue with this atomic radius. What happened, Daniela? At what time you normally wake up on Sundays? 7:30? So early? Good. Huh? Ah, okay. Mr. Oswald. Now the last down good task. What you said? 1 or 2? Afternoon. Couldn't it put together? At what time you sleep like 1 o'clock and you wake up at 1 o'clock, 2 hours sleep? Okay, no problem. Normally on Sundays, 9. Normally on Sundays, उठल्यावर बरं झालं दिस पण झाला होता. Normally on Sundays, at what time you wake up? परत येऊन आफ्टर मीस परत येऊन निघता. हा त्यांना माहिती कितल्या उठता? वर्षी नॉर्मल संडे कितना उठता? सर बेस्ट है ना काम मार बोलो. Exact time 8:15. 7 o'clock. 7:30. मिस्टर Oswald. मैं परत येऊन पुरतो नेता परत नेता. हा त्याने कितल्या उठता मग पुरतो नेता? After mass you sleep again. नीट आणि जेई क्रॅक करपाचें आमकां न्ही. डॉक्टर आनी इंजिनियर जावपाक जाय न्ही आमकां. चेंज ऑफ टायम टेबल आतां सांगून दवरता. Try to sleep. See, there is always your peak time of your study. You know your peak time of your study? My peak time is morning, early in the morning, like 5 to 7. If I study 5 to 7, no, my time to if I study 5 to 7, no, it is study of my 8 hours or 6 hours in just 2 hours. I can do study of 6 hours in those 2 hours. That much I have, 5 to 6. My peak time during my college time. For 5 to 6 hours study fit. I will never forget it. So like that you find out what is the peak time of study. That time of study you know that thing. What is mostly night I don't know night. Okay, no problem. But night time study. What's the peak time? You know, morning. Yes, what's the peak time? Night. Time. After. Actually, it is in the morning only. Okay, so please find out your peak time. Find out your peak time. It is important. Okay. Now we'll go for the next part of the atomic radius. The application questions that are. See, I'm just marking the things. Across the period The atomic radii decreases with increase in atomic number. See here. Interesting topic here. Lithium, sodium, potassium, rubidium, and cesium. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. The thing here is atomic radius across the period. Across the period. That is also called as left to right. Atomic radius down the group. Two things are there. Down the group. I will keep it very simple. I will keep it very simple. Down the group, पहले explain करूँ. Lithium electronic configuration 1s2, sorry 2s1. This will be 1s2, 2s2, 2p6, 3s1. This will be 4s1. This will be 5s1. This will be 6s1. So down the group, the shell size is increasing. Number of shells what increases? Lithium कितने shells are? What is atomic radius? Distance from the center of nucleus to the outermost shell. In lithium, how many shells are there? 2. Sodium, 4. Sorry. In sodium, how many? Last outermost shell is what? 3. Potassium, 4. Rubidium, 5. Cesium, 6. Strontium, 7. So what happens to the size of the shell? What happens to the number of shells? They are increasing. So if the number of shells are increasing, what will happen to the atomic radius? Increases. Very simple. Down the group, the number of shells are what? Increases. So atomic radius also increases. Clear? Very simple. Atomic radius. Uda surtalo. Yes. Sure. Ata. Across the period. Across the period. Atomic number is increasing. 3, 4, 5, 6, 7, 8, 9, and 10. Correct? But are the shells increasing? Are the shells increasing? No. See, here 1s2, 2s1. Here 2s2. Here it will be what? 1s2, 2s2, 2p1. This will be 2p2. So last electron will be what? 2p6. So the electrons are in the same shell. The electrons are in the same shell, yes or no? Here the shell number is what? 2. Here the other shell number is what? 2. So atomic radius is that low. It will remain same. It will increase or decrease. Just asking. I will tell. Don't worry. What do you think? Down the group clear asani. Shell size increase data, so atomic radius automatically is that law. It will increase. What happens across the period since the electrons are in the same shell? What will happen? Increase, decrease. Kidya? Okay, shell same asani, right? Second, what is, see, atomic radius nucleus, center of the nucleus is outermost shell. So the सगळ्यांचो shell आमचो इलेक्ट्रॉन कितें आसा पळय तें मागीर पळोवया. Shell same उरतलो न्ही. So distance same उरपा जाय न्ही. No. Atomic radius decrease जाता. See. The reason here is effective, very important word, very important word. Effective nuclear charge increases, which can be also given as Z effective. Don't ever forget this thing in my class. What is effective nuclear charge? Don't ever forget. Very important thing I'm telling you. See, in lithium, beryllium, boron, how many electrons are there in the second shell, first shell? Lithium. Second shell, 1 electron. Then in beryllium, second shell, 2 electrons. In boron, how many? 1, 2, and 3 electrons. Correct, no? Second shell, I'm talking about second shell. Here it will be how many? Here it will be how many? 1, 2, 3, 4. So, since the electrons are adding in the same shell, the number of electrons are adding in the same shell, due to which the force of attraction from the nucleus to the outermost shell increase जाता. म्हणजे तो एक इलेक्ट्रॉन पुल करपाक चड फोर्स लागपा ना, yes or no? As compared to how many electrons? 4 electrons. Are you getting the things here? So as the number of electrons in the second shell is increasing, the force of attraction from the electrons in the outermost shell and the nucleus is what? Increases. The force of attraction जर increase जाता, what will happen to the radius? Decreases. And this is called as effective nuclear charge. So if the force of attraction increases, Z effective, that is effective nuclear charge also increases. And why the force of attraction increases across the period? Because the electron enters into the same shell. As the electron into the same shell increases, the force of attraction from the nucleus to the outermost electrons increases, as a result of which effective nuclear charge increases and the atomic radius decreases. Understood? Same thing with the third period, same thing with the fourth period. Are you getting the things here? So आमका ये important. Down the group atomic radius, reason with reason को परस्पर है. Down the group atomic radius increases. Why? Because number of shells increases. Across the period, atomic number increases. Or force of attraction increases. Effective nuclear charge increases. Atomic radius decreases. Very simple. Understand like this. Understand like this. So write and keep. पण ते वाचपा गेला difficult जातलें. So write and keep like this, like this. Atomic radius, force of attraction increases, Z effective increases, atomic radius decreases. Here, number of shell. Okay, I'm एक point पर here also one more point. Atomic number increases. Here number of shells increases. So atomic radius increases. Keep it very simple. Keep it very simple. Done? Two, three faces are dull today. I don't know what happened to them. These are like beginning issue problem, Sunday, Kutpa problem, all. Two, three faces are dull. What happened, Lisa? What she has written? Okay, ask me, no, I will tell you. This is number of shell increases, atomic radius increases. This part you will use only for revision. This is revision. शिक्षकांना रिवाइज करतो. What happened, Daniela? So you are not 100% today. नीट जाऊ ना. Very. Not getting. Not understanding what you are saying. What is she has used? Giddy. Baba. Sorry, Dizziness, I understand. Giddy first time. The first time I tell him. Janji. Okay, no problem. See that? You want to go early? Just 1 minute. You want to go early? Sure. जर त्रास झाला सांग मला. Okay? सांग. Effective nuclear charge. That is किती सांग. Atomic number increase जाता. Atomic number of shell increase जाता, atomic radius increase जाता. Number of shell increase जाता, atomic radius increase जाता. Take care of your health, please, everyone. Exams are nearby. The weather around us is totally different, you know. आज गरमी जाता, मदींच पाऊस पडटा, मदींच परत गरमी जाता. रातची AC लायल्याशिवाय न्हिदपा जायना, फॅन लायल्याशिवाय न्हिदपा येना. And this is the month of July. If your month of July is feeling like March, just imagine when March will come. Okay, so on that page, just check the last paragraph now. Understood the concept now? On the page number 3, check the last paragraph. Across the period, the magnitude of nuclear charge as addition of electron take place in the same principal shell. Same principal shell म्हळ्यार कळ्ळो न्ही? Same shell. Electrons are pulled closer to the nucleus by increasing effective nuclear charge. Therefore, atomic size decreases across the period. Understood? Clear asa? Okay. Next page. Ata more applications on atomic radius. More applications on the atomic radius. Just be with me here. All of you know now what is atomic radius. Down the group atomic radius किती जाता? Increase. Across the period atomic radius किती जाता? Decrease. कित्याक लागून decrease जाता? Electron enters into the same shell. So force of attraction किती जाता? Increase जाता. Effective nuclear charge किती जाता? Increase जाता. Atomic radius किती जाता? Decrease जाता. पण त्याची पयली एक word बरोवपाचो. Across the period atomic number also increases. हे सुद्धा बरोवपाचें. Across the period atomic number also increases. Clear? Okay. Achha, just check this graph. Sometimes in schools, this graph will be given and they will tell you to identify the element A, B, C, D. दिश्टी पडटा helium, beryllium, boron, so B दिश्टी पडना पळय. So mark that boron clearly. Page number 4 graph. Beryllium, that is not helium, student, that is lithium. So helium बरेल पळय, तो lithium कर पळय. That helium is written, no, make it lithium. Make it lithium, okay. Lithium, beryllium, the third one is boron, carbon, nitrogen, oxygen, fluorine. Atom. See the interesting thing. What is the graph made up of? Atomic number and what? Atomic radius. Can you see now? Atomic number, atomic radius. So, Maksang, as this is graph of across the period or down the group? Across the period graph is given. Across the period. Which period dila amka? Second period dila. Yes. So across the period आमगे atomic radius किती जावपा जाय? Decrease जावपा जाय. Everyone accept this. Decrease जावपा जाय. So be with me here. Lithium to beryllium decrease जालो. Yes. Beryllium to boron decrease जालो. Boron to carbon किती जालो? Decrease जालो. Carbon to nitrogen किती जालो? Decrease जालो. Nitrogen to oxygen किती जालो? Increase जालो. And oxygen to fluorine परत किती जालो? Decrease जालो. So in P block, they are P block elements. So in P block, there is some exception. Exception? Just let me read this. In nitrogen, electronic configuration is given. See, when we move from nitrogen to oxygen, the nuclear charge increases by 1, but at the same time, it has 2 electrons in the 2p orbital. The electron in the same orbital repel each other, and inter-electron repulsion outweighs the effect of nuclear charge. That is why the size of increases from nitrogen to oxygen. Correct? Nani? Samsara. Samsara. Don't worry. Asani Azuna. Samsara. Try to understand this. Nitrogen to oxygen, I'm going to Zarani. Opa graph we can ignore. But it has a lot of meaning. Same question again, this will be repeated again in P block. P block chapter. So, आता clear करूया. Nitrogen electronic configuration, atomic number किती आम गेलो? 7. Electronic configuration किती 1s2, 2s2 आणि 2p, 2p3. 2p3 मार पडटलो. समीक्षा म्हणून सांग 3 आणि 4. Okay, 1, 2, 3, 4, 5, 6, 7. Yeah. Meaning point. Very interesting concept. Oxygen atomic number किती 8. Vedal electronic configuration चा oxygen 1s2, 2s2, 2p4. Very good. 1s2, 2s2 आणि 2p4. एक सांगता आम्ही 1 to 33 आम्ही सामके बॉल मारून शिकले आणि एक्झामी इलेक्ट्रॉनिक कॉन्फिगरेशन किती विचारता आणि तो सोडियम, सल्फर, ऑक्सिजन. Your teachers will ask in some schools. See, जे कोणाचे फोकस केला chromium +3, chromium, copper. So don't make mistake for the simple ones. Please. सरांन सांगला chromium +2 शिक, chromium +2 शिक. आणि आयले किती एक्झामी ऑक्सिजन. आणि we have written wrong thing. Please असले करू नाका. So 1s, 2 electrons, 2s, 2 electrons, and 2p. 1, 2, 3. अच्छा किती जातात students ना? If I am a 2p subshell, माझ्याकडे 3 इलेक्ट्रॉन असा, हा ओग्गी रावला. म्हाका रे आडेक तो 1 इलेक्ट्रॉन आयला ती जातलो. Electron repulsion start जातले. Electron has a negative charge, yes or no? Electron has a negative charge. So हांगा ते electron किती जावपा लागले? Increase जावपा लागले न्ही. Electrons किती जावपा लागले? They are increasing, yes or no? In for one or there were electrons in one orbital each here, one. They were good, happy. When this electron comes, this is also a negative charge, this is also a negative charge. So there will take place? So the repulsion is so much that it outweighs. What important? Outweighs म्हटल्यार तो तेका neglect करता, delete करता. There are two things here. एक आसा effective nuclear charge and दुसरी कितें आसा inter-electronic कितें repulsion. So effective nuclear charge म्हटल्यार हांगे atomic radius decrease जावपाक जाय, yes or no? But inter-electronic repulsion is so much that it outweighs. तो तेका cancel करता कोणाक? Effective nuclear charge cancel करता. कोण cancel करता? Inter-electronic repulsion. See, this is nucleus. This is for nitrogen. This is for oxygen. How many electrons we have in the P? 2p. 3 electrons. And how many oxygen this is in 2p I'm talking about. And how many electrons in 2p in oxygen? 1, 2, 3 and what? 4. So when this one electron comes, anki jawaba lagtale inter-electronic repulsion. But Z effective will be there for both. Z effective will be there for both. Z effective will be there for both. So here Z effective is more than what? Inter-electronic repulsion. Z effective is more than what? Inter-electronic repulsion. So automatic atomic radius is decrease. But here also Z effective is there. But here what is more? Inter-electronic repulsion is more than what? Z effective. आता जर inter-electronic repulsion जर चढ आसा, Z effective outweigh करता. Outweigh म्हणजे meaning कळ्ळें? Cancel करता. So what will happen to the size of oxygen? Increase जातलो का decrease जातलो? I or D? I. कळटा meaning? Without कळना? ना? Okay. See, effective nuclear charge म्हळ्यार कळो? Force of attraction from the nucleus to the outermost electron. जो असो ओढून दवरता आपणाक. So atomic जशी electron increase जातले outermost शेलाक, effective nuclear charge किती जातलो? Increase जातलो. But just as the electrons are increasing, there will be inter-electronic repulsion. Inter-electronic मुळे कितें? Electron repel जातले न्ही? कितें एक electron दुसरे electron दोगांचे भितर negative charge आसा. So repulsion जावपाक लागतलें. So what happens here in oxygen? हे inter-electronic repulsion जे आसता, it is more. So inter-electronic repulsion जाता म्हळ्यार automatic size किती जावपाक लागतली? इलेक्ट्रॉन जर रिपेल जाता जाल्यार increase जावपाक लागतली न्ही? Effective nuclear charge आसा, but तो inter-electronic repulsion is so much that it cancels that effective nuclear charge. तो तेका pull करून दवरपाकूच शकना nucleus. So automatically what will happen to the size of oxygen atom? मातशी किती जावपाक लागतली? Increase. But actually ती किती जावपाक जाय across the period? Decrease जावपाक जाय. Why it is not decreasing? Why it is increasing? Because here inter-electronic repulsion is more than what? Effective nuclear charge. Inter-electronic repulsion outweighs what? Effective nuclear charge. Are you getting the things now? Are you getting the things now? Clear, Asaf? Yes? So I will read that again. In nitrogen, electronic configuration is given. When we move from nitrogen to oxygen, the nuclear charge increases by 1. But at the same time, it has 2 electrons in 2px orbital. Yes or no? The electron in the same orbital repel each other. And inter-electronic repulsion outweighs the effect of what? Increase in nuclear charge. That is why size of increases from nitrogen to what? Oxygen. The topic. Now, आता कळ्ळें वाचून? आता वाचतरी अंडरस्टँड जालें? क्लियर आसा? ओके? नेक्स्ट कॉन्सेप्ट. आणि एक कॉन्सेप्ट करूया. इन फ्लोरीन आता आणि क्वेश्चन पळय. How much the concept is going? See, here it is 2p4. Here it is what? 2p5. आता वही बी साइज इंक्रीज जावपाक जाय न्ही? हांगा बी इंटर-इलेक्ट्रॉनिक रिपल्शन आसतलें न्ही? येस और नो? कळटा कितें सांगता? बट हेजो साइज किती जाली आता? डिक्रीज जाली. कित्याक लागून सांग पळोवया? बिकॉज आता हांगा 5 इलेक्ट्रॉन आसात. सो हांगा इफेक्टिव्ह न्यूक्लियर चार्ज वॉट? Outweighs whom? Inter-electronic repulsion. This is chemistry. This is chemistry. Can you see how each element is changing? and you see how each element is changing. आणि एक बारीक extra information सांगून दवरता. Nitrogen is very dangerous. नायट्रोजनाचो इलेक्ट्रॉन काढपाक आमकां व्हेरी डिफिकल्ट. सांगपाक शकता कित्याक तो? हें सांगलेलें आहे. नायट्रोजनाचो आमकां जर इलेक्ट्रॉन काढपाक जाय न्ही, डिफिकल्ट. वाय? एनीवन? ऑक्सिजनाचो इजिली काढपाक शकता. फ्लोरिनाचो बी म्हाका एक टायमार फ्लोरिना काढपाक नाका. नायट्रोजनाचो इलेक्ट्रॉन काढपाक डिफिकल्ट जातलें. कॅन एनीवन टेल? I have done this. I know. During electronic configuration, एक बारीकसा पॉइंट सांगला हांवें 10 मिनटाचो. नायट्रोजनाचो इलेक्ट्रॉन काढपाक डिफिकल्ट. चड एनर्जी लागतली, खूब एनर्जी लागतली इलेक्ट्रॉन काढपाक. कॅन एनीवन? हाफ फिल्ड आसा न्ही. सो हाफ फिल्ड म्हळ्यार कितें? स्टेबल. नायट्रोजन आपूण स्टेबल आसा, अनस्टेबल करपाक दितलो तुमकां? ना. एक इलेक्ट्रॉन काढपाक दितलो? ना. सो तो इलेक्ट्रॉन काढपाक आमकां एनर्जी ऑटोमॅटिकली किती जातली? चड लागतली. This will I will make you understand in P block. Okay. आता फ्लोरिनाचे just point वाचूया. In fluorine, the electronic configuration given. Electronic configuration we already know. Charge increases by 1 and the repulsion also increases. Yes or no? In fluorine, the repulsion also increases. But here, see, the nuclear charge outweighs what? The effect of what? Inter-electron repulsion, and hence size decreases from oxygen to fluorine. Clear asa? Exam question आयल्यार I want you to write this answer. कशें बरोवपाचें तें सांगता आन्सर कसो बरोवपाचो. You can either follow that method. आता जर नायट्रोजन आनी ऑक्सिजन क्वेश्चन विचारलो कित्याक इन्क्रीज जाता काय म्हणून, नायट्रोजनाचे इलेक्ट्रॉनिक कॉन्फिगरेशन बरोवपाचें, ऑक्सिजनाचे इलेक्ट्रॉनिक कॉन्फिगरेशन बरोवपाचें आनी मागीर जस्ट स्टार्ट रायटिंग. What you will write? In nitrogen, there are how many electrons in 2p? 3 electrons. So effective nuclear charge is, because of effective nuclear charge, the size of atomic size of nitrogen decreases. When we move from nitrogen to oxygen, 1 electron is added. In whom? Oxygen. So that is why there will be what? Inter-electronic repulsion. The inter-electron repulsion is so much B, so much high that it outweighs whom? Effective nuclear charge. As a result of which, the size of oxygen from nitrogen to oxygen, the size increases. Again, oxygen to fluorine. In fluorine, there is 1 more electron. So as a result of which, there will be inter-electronic repulsion. But in fluorine, the effective nuclear charge is so more that it outweighs what? Inter-electronic repulsion. As a result, from oxygen to fluorine, atomic size what? Decreases. See how concept is atomic radius. Definition ऐकलताना बरें दिसलें. Center of the nucleus to the outermost shell. Now just imagine this we have studied only for the one period. Just imagine how many periods we have across the period. D block athlete, D block. D block elements imagine कर atomic radius किती जातली ती. मदी D5 आसा, मदी 4s1 D5 आसा, मागीर D6 भितर pairing start जाता, D7 pairing start जाता, inter-electronic repulsion. Just imagine DNA block chapter येतलो, how the atomic radius will change. Clear as a topic ata? Yes. Just take 2 minutes to break here and we'll. Okay, let's finish with the atomic radius. Let's finish. Magi. Oh, same case. Now, P block आमरे खूबशे exception cases आसात. हांव तुका जनरल अशें सांगपाक शकना की it will happen for every P block element. In P block there are some exception cases. कितें exception cases सांगतो आता तुका एक example सांगता. बोरॉन, एल्युमिनियम आणि गॅलियम डाउन द ग्रुप सायज किती जावपाक जाय आमगेली? इन्क्रीज जावपाक जाय. पूण गॅलियमाची सायज लेस आसा एज कम्पेअर्ड टू एल्युमिनियम. आता हांगा लॅन्थोनाइट कॉन्ट्रॅक्शन बी ना, शिल्डिंग इफेक्ट बी म्हणून कन्सेप्ट येता. आय विल नॉट गो इन दॅट, बट शिल्डिंग इट इज देयर एक्चुअली एक्सप्लेन शिल्डिंग इफेक्ट. बोरॉन, एल्युमिनियम, गॅलियम जर आमगेलो डाउन द ग्रुप, दिस इज ग्रुप नंबर 13. डाउन द ग्रुप की सरांची सांगला atomic radius किती जाता? इन्क्रीज जाता. जनरली इन्क्रीज जावपाक जाय न्ही, बिकॉज नंबर ऑफ शेल किती जातात? इन्क्रीज जातात. बट जेन्ना बोरॉन टू एल्युमिनियम इन्क्रीज जाता, एल्युमिनियम टू गॅलियम डिक्रीज जाता, मागीर परत सेम उरता. शेल पळय, 3rd to 4th, 4th to 5th. रिजन सांगपाक सांगता. रिजन जाल्यार सांगो. आतां विचारलें पूण म्हाका एक फावटी म्हाका विचारलें, म्हाका सांगपाकूच जाय. एल्युमिनियमचे इलेक्ट्रॉनिक कॉन्फिगरेशन कितें आसतलें? 3s आणि 3p न्ही. ते गॅलियमाचे इलेक्ट्रॉनिक कॉन्फिगरेशन d ऑर्बिटल आसतलो. 4s आणि 4p न्ही. बट हांगा कोण आसतलो मदीं? 4s आणि 4p मदीं 3d आसतलो न्ही. Yes or no? D electron जे असता पळय D ऑर्बिटलां जे इलेक्ट्रॉन असता पळय दे शो पुअर शिल्डिंग इफेक्ट. पुअर शिल्डिंग इफेक्ट म्हळ्यार कितें सांगता? स्टोरी सांगची पडटली. इमॅजिन तुमगे एग्जामीचो लास्ट पेपर जालो. लास्ट पेपर, ओके, एका पेपर सोंपता आनी यू नो हू इज युअर फेमस पर्सनॅलिटी, एनीवन यू वॉन्ट टू मीट? Anyone you want to meet, any famous personality? No one? कोणा मेळपा नाका लायफान बरें? Yes? No? No one? Justin Bieber and all, any singers, Akon. Akon is my favorite. Huh? I still listen to that song, Beautiful. I cannot sing, but I listen to that song. You know? Beautiful something. I cannot say also. I'm gonna. It's so beautiful. Something is there. Yeah, can you sing for me? Icona Baconaचे song famous for ते समजे त्याच्यानंतर तो जेली गेलो. After that 2 years we went in jail. जेली असतो तो थोडे दिवस ना. You know, something on the breakup thing. This is the song. That is the favorite song. I also listen to it. Yes. सांगू शकता एक फर्स्ट लाइन, दोन लाइन? I don't know. Yes, 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 yes. Famous आहे का ते? Famous. Okay. So, okay, famous. कोणालाच कोण famous ना? कोणा we want to meet someone famous personality? No one. अरे बाप बाप. No one. तुझा? Me. म्हाका मेळपा बी केन्ना मुखार दिसली जाल्यार ऑटोग्राफ बी घेवपा इफ आय बिकम फेमस. नो नो खंय मरे? अरे हाऊ इट इज पॉसिबल? अमिताभ बच्चन, वरुण धवन, कोणच ना रे तुमगेला एक्टर्स एंड फेमस? सांग. अच्छा नाका तेगे नाव प्रोनाउन्स करपाक म्हाका डिफिकल्ट जाता आनी कोण सांग. Ronaldo, Messi. So imagine Messi is supposed to come in your school. Which school you are? Sorry, Rosary. Rosary न्ही? So Rosary Messi येवपाचा मेळपाक. स्पेशली तुका Messi मेळपाक येवपाचो. हे पेपर एका सोंपता तो 12:30 बरोवन भायर Messi येवपाक म्हणून. How the situation is? Messi आयलो, Messiचे बॉडीगार्ड आसतले न्ही अराउंड. Bodyguards are electrons, huh? Yes. Bodyguards are the electrons and Messi is the nucleus, center of attraction. भुरग्यां 3-4 फ्लोर आसात. तो भुरगीं रावल्या सामके. आतां बॉडीगार्ड जातले मागीर कोण आसतले? जीपी आमगे जीपी म्हळ्यार कळ्ळें? गोवा पुलीस. ओके. आफ्टर दॅट मातशें इल्ल्यान दिल्यार सोडटले सुद्दां, काय प्रॉब्लेम ना. तो समज सॉरी कोणा फादर मदर कोण पुलीस बी आसा सॉरी. ओके. हांव डायरेक्ट सांगता. मागीर पुलीस असतले, मागीर आमगेले एमएलएस, मिनिस्टर्स, मागीर कोण? अदर पीपल, भुरगीं. हें सोड न्ही. क्लियर न्ही? Consider the MLAs, the line of MLAs, the D block element. Line of MLA is the D block element, electrons. So D electrons जे किती करतात? No, they are poor shielding effect. म्हटल्यार if a nucleus want to pull the electron, एक इलेक्ट्रॉन येता, कोण येता आमगेलो? Gerald is coming. Electron, outermost electron येता. And if there are D electrons, so nucleus कोणा पयली pull करतलो? Gerald or the D electron? D electrons, correct न्ही? Because it's already there, no? But D electrons show poor shielding. म्हटल्यार कितें? ते इलेक्ट्रॉन पुल करपाक तितली इफेक्ट जायना. He will pull that electron. He will pull. So in gallium, outermost electron is 4p, न्ही? But there are D electrons here. So हांगा ऑटोमॅटिक सायज किती जावपाक जाय? इन्क्रीज जावपाक जाय न्ही? 4p म्हटल्यार इन्क्रीज जावपाक जाय न्हू? But since these two D electrons show poor shielding effect, poor screening effect, म्हणजे स्क्रीन करपाक इजिली दिसले जेरलाक. मदीं कोण येवपाना. मदीं जर डी इलेक्ट्रॉन आसा तो तांकां पुल करतलो न्ही. इफ ते डी इलेक्ट्रॉन्स मदीं आसा ते हेच करना, स्क्रीनूच करना, दे शो पुअर स्क्रीनिंग इफेक्ट, तो कोणा पुल करतलो? ते इलेक्ट्रॉन फ्रॉम पी हेच सोड न्हू. सो ते इफेक्टिव्ह न्यूक्लियर चार्ज किती जातलो हांगा? इन्क्रीज काय डिक्रीज? इफेक्टिव्ह न्यूक्लियर चार्ज किती जातलो इन गॅलियम? इन्क्रीज जातलो. बिकॉज ऑफ वॉट? पुअर स्क्रीनिंग ऑफ वॉट? डी इलेक्ट्रॉन्स. आमी 4p इलेक्ट्रॉन्स सामको पुल करून घेतलो. जेरला थंयच्यान सांगतलो यो. लोक शॉक सामके. जेरला थंयच्यान सांगतलो कम. सांगपाक शकना. डोंट से लायक दॅट. ऑलवेज हॅव अ पॉझिटिव्ह माइंडसेट. कितेंय जावपाक शकता लायफान भितर. वी डोंट नो. ओके. सो ही विल पुल दॅट p इलेक्ट्रॉन्स. सो ऑटोमॅटिकली इफेक्टिव्ह न्यूक्लियर चार्ज इन्क्रीज जातलो, सायज किती जातली? डिक्रीज जातली. सो दीस आर सम पॉसिबिलिटीज. देर आर सम थिंग्स. सगळे सांगपाक गेल्यार आयज क्लास हांगा सोंपतली एटॉमिक रेडियसान. Anything certain. So बारीक सा concept for atomic radius. एक बारीक से एक revision करिए. What is atomic radius? Distance from the center of the nucleus to the outermost shell. So down the groove atomic radius किती जाता? Increase. किती झाला increase जाता? Number of shells increases. Okay. Across the period किती जाता? Decrease. किती जाता? किती झाला पण? Across the period. First point किती सांगताले? Atomic number increases. So number of electrons in the same shell increases, because of which effective nuclear charge increases. Atomic radius decreases. Very simple. आता across the period nitrogen to oxygen मध्येच atomic radius किती जाता? Increase जाता. Because nitrogen to oxygen एक electron किती जाता? Add जाता. In which atom? Oxygen atom. Because of it inter-electronic repulsion किती जाता? Inter-electronic repulsion takes place, and the inter-electronic repulsion is so much that it outweighs what? Effective nuclear charge. Clear as oxygen to fluorine. Again what? One electron is added. So there is also what? Inter-electronic repulsion. But here effective nuclear charge what? Outweighs whom? Inter-electronic repulsion. So oxygen to fluorine. Nuclear charge what? Sorry. Atomic radius decreases. Clear? Clear? Okay. And एक बारी सपाट करिया. Variation of atomic radius down the group. आता down the group पुढे. Down the group. आता एक point explain करतो आपण. See. What happens down the group? It's simple as down the group is just 2 minutes. किती जाता? Down the group atomic radius down the group increase जाता नी? Increase जाता. See हा? The atomic radius of element increases from top to bottom in a group, while down the group there is increase in the principal quantum number. That is what? Number of shells. Although the number of electrons in the outermost shells remain the same. The valence electrons are far away from the nucleus. The inner electron shield the outer electron and pool of nucleus. Therefore, the size increases as we go down the group. Now, सांगता. See, lithium, sodium, potassium, rubidium and cesium. किती म्हणतो तो? This is 2s1, this is 3s1, this is 4s1, this is 5s1, this is 6s1. Outermost electron खंयची shell आसा? एक 3, 4, sorry, 2, 3, 4, 5, 6. How many electrons are there? 1 electron is there. So shell किती आसा? Increase जाता. Atomic radius किती जाता? Atomic size किती जावपाक जाय? Increase जावपाक. But याद धर. Fourth shell आयलो म्हटल्यार हांगा d electrons येतले. हांगा बी fifth shell आयलो d आणि f electrons. D as well as f electron also show poor screening. कळ्ळें न्ही? MLS. D as well as f electron also shows what? Poor screening. हांगा बी कोण आयले? D आणि f आयले. So see, so graph पळय. Graph पळय. Lithium to sodium, that 151. Lithium to sodium increase जालो पळय. Yes? Sodium to potassium किती जालो? Increase. Potassium to rubidium मातशें सेम उरपा लागले न्ही? रुबिडियम टू सिजियम मातशें कितें उरपा लागले? सेम. म्हटल्यार हांगा न्यूक्लियर चार्ज कितें जावपा लागलो? मातसो इन्क्रीज जावपा लागलो. I know it is increasing. Atomic radius in the graph is increasing. But is it a sudden increase or steady increase? Steady increase. कळटा आतां? Shells increase जाता पळय. म्हळ्यार सायज सामकी खूब increase जावपा जाय न्ही? बट सामकी खूब increase जाता? No. मातशें steady increase जाता. कित्याक हांगा तो पॉयंट आयलो जो which I explained. Poor shielding effect. So हांगा बी D सबशेल येवपा लागले. D electron येवपा लागले. And D electron, F electron shows what? Poor shielding effect. So in this three, effective nuclear charge किती जावपा लागतलो? इल्लो increase जावपा लागतलो न्ही? ते भायले जो last electron जो आसा पळय ताका pull करपा लागतलो. But it is not that much. It is not that much. So that atomic radius suddenly decrease जाता. It happens here in gallium. जे P block टायमार ते सांगतो तुमकां. So clear with this thing. See for last also fluorine, bromine आणि iodine पळय. Fluorine to chlorine सामको sudden increase जाता न्ही? But chlorine, bromine, iodine मागीर परत किती जावपा लागलो? Steady जावपा लागलो. Clear आसा ना topic? Okay, so एक 5 मिनिटाचा ब्रेक घेऊया. 5 minutes. You want a big break of 15 minutes and all? Yes? आता घेऊया का मागे घेऊया? 9 to 10:30. Break 15 minutes break घेऊया. 10:45 to 12:15 will continue. म्हाका आता मदीं परत ब्रेक नाका म्हणून सांगतो तुका. घेत जाल्यार आतां घेऊया. Because these concepts I have to do it in one shot. Don't worry, I will not able to finish. I think the one is complete. But the concept that should be in one shot. Clear now? So 15 minutes break here and we'll continue again.